Good. Should we talk about some hardware hacking? Okay. Cool. So my name is Joe Grand, and I am an electrical engineer by trade. It's sort of what I do. I love electronics. I live it. I breathe it. I've been involved in electronics since I was about 7 years old and started building projects out of magazines and just opening things up and seeing how they work and breaking things and taking apart broken things and taking apart non-broken things and breaking them. It's just something I've loved to do. I've always loved being able to think of something and build it and see it working. When I was a kid, that wasn't really the coolest thing to do. To be involved in computers and electronics was sort of like having a big spike on your head or something. Everybody just kind of looked at you and laughed and everything and pointed, but now I'm laughing, so it's okay. I just figured as long as I was doing what I love to do, then it didn't matter what other people thought, which is also part of the hacker mindset. So, you know, not even just hardware hacking, the hacker mindset in general. If there's something that you love and something that you want to do and something you believe in and something that you try, it doesn't matter what anyone else says. So we're going to talk about hardware hacking, and there's a few kind of things about hardware hacking. I tried to kind of break it into a few different areas, but one is about learning and having fun and the curiosity side of things. It's like, how does that thing work? Just seeing how things are working, having fun with it, experimenting, like these, you know, like the badges you guys have, kind of tinkering with those. That's an important part. Maybe solving a difficult problem. Maybe there's like some cool thing you're working on, some project or something that you're like, I wish I had a way to control this robot. Or I wish I had a way to do something with this toy, or like turn this toy into something cool. Then you can do that with hardware hacking. Anything that you can think of, you can make. And that's what's so cool. Just like with software, but with software you can't really see it, right? You can kind of, sometimes you can see the results, but hardware you can always see. In electronics, you can change one thing and it will change everything. And that's what's so cool about it. Maybe doing something that's never been done before. If you know, again, if you have something that you're thinking of and maybe something hasn't been done. So that might be something like, let's see, what's a good example of that? I don't know, maybe like the 3D printers. A few years ago, there was no easy way for somebody to just print out their own object. So it had really never been done on a scale. You know, they had big 3D printers and things for big companies, but there was nothing that like me and you could just go and build and make something. So that's sort of hardware hacking. It's like creating something that's never been done and doing something really cool with it. I'm sure you guys have heard this in every single talk at R00tz Asylum. Not breaking the law. That's an important one. Trust me. You don't want to break the law when you do this stuff. And the laws have changed a lot since I was a kid. I could get away with a lot more than what you guys can get away with, just because technology wasn't understood, the internet wasn't understood, electronics and hardware, like all this stuff. I tried to explain stuff to my parents and they sort of got it, but the government was in a different world. So things were just different. But nowadays, you know, you have so many opportunities that you don't have to break the law to learn stuff. You can come to places like this. You can go to DEF CON. You can go to your hacker space. You can go to your school who probably has, you know, a computer lab or some electronics things. So there's so many places that you can go that you don't have to kind of reach outside of the law to do things. And that's a really important thing. So I'm going to go through like some maybe famous hardware hackers that you may or may not recognize. Just to let you know, like hardware hacking has been going on for a long time. It's not just since, you know, the Arduino processor maybe, or in the past few years. It's been going on for hundreds of years. This old guy is Thomas Edison. You guys remember what he developed, what he created? The light bulb? That's right. So among lots of other things, he's pretty much the most famous for creating the light bulb. And I think, let's see, do I have it in my notes? There's some controversy about how many times he tried to develop the filament and the right design of the light bulb, but it was some thousands of times. So he tried all these different things and just kept failing, and over and over and over and over and over again. And then he got it right. And he got the one setup that was just perfect, that would be low cost and that would last a long time. And that's part of the hardware hacking mindset. It's trying things over and over again until you get it the way that you want. And he took a lot of, everybody was making fun of him. Like, you're never going to do it. You're never going to be able to figure out, how to make an electric light bulb that's good. And he didn't listen to them, and that's another important thing. How about these guys? Steve Wozniak, Steve Jobs. You recognize those names? Do you know what company they created? Apple? Yeah, so here are pictures of these guys back in the day when they were young. Maybe like your parents' age or something. No, probably younger than your parents. They were basically kids. And on the left, that's Steve Wozniak with something called a blue box, which is a device that you used to be able to use to essentially travel through the phone system using different types of sounds. And that was something where it wasn't, that was kind of on the edge. This was way back. This was 50 years ago. But that was kind of like, I don't know if it was totally illegal, but it wasn't totally legal. But this was the way he was hacking and he was learning. But that, and so Woz's kind of fascination with electronics and with the telephone system is what led him to develop the Apple computer, which is just amazing. And then showing down here, that picture, I don't know if you can see in that box, there's a little circuit board in there. That's the first Apple computer that came as a kit. You had to build it yourself. It didn't have a keyboard. It didn't have a monitor. You had to kind of hack stuff together, and that's where things were back in the day. Lots of hardware hackers. But then things sort of went away as the software or computers became more common in the internet. People kind of shied away from hardware and went back to software. So it's always been my thing of trying to get people back into electronics and get people back into hardware. There's a more recent picture of Steve Jobs with the MacBook. So creating something new with hardware hacking. I want to show you just a few projects that I worked on when I was a kid, just to kind of give you an idea of what you can do, maybe inspire you a little bit to say, oh, I'm going to try to build something like that. Little mischievous devices. The one on the top is a little hard to see. That was the first circuit board that I ever made. And all it has on it is two resistors, so there's not much to the circuit, but that would plug into the telephone line. I don't know how many of you guys actually have telephones that plug into things anymore, but I still do. Probably by the time you're older, you're not going to have telephone lines at all. But this thing plugs into a telephone line, and you can use the phone as normal from your house. You can call your friends and everything. But if somebody tries to call you, it appears as a busy signal. So it's fun to kind of mess with people. And I used it to prevent sales guys from calling our house during dinner. And I was worried that teachers were going to call my parents and tell them about, what I was doing at school. So I'd plug this thing in so no one could call my parents, and I could always they could still use the phone like it was nothing. Oh yeah, okay, so let's see some other ones. The lower corner, that little box. Have you guys seen projects that are built into like Altoids boxes and little kind of candy boxes that you can do these days, little kits you put inside of candy boxes because it's like a good size? This was a box from a long time ago, similar type of concept. And I built a circuit, pretty basic circuit, that would just generate a really high-pitched sound. And when you have high-pitched sound, high-frequency sounds, it's hard to locate where it's actually coming from because it bounces all over the place. So what I did is I built this circuit, put it inside of this box, which was for like cough drops, and then I'd sit in class. This was in high school. I'd sit in class, turn this thing on, and put it on my desk, and it would just, this noise would just be like, everyone would be like, oh, what is that sound? But no one could figure out where it was coming from. The teachers couldn't figure it out or anything, so it was totally great. And then the final one is something that I built towards the end of high school. And I'd heard about this kind of as rumors, where you could have a laser and shine a laser off of a window and get the return of the laser based on vibrations of the window. The return laser would be modulated with the audio that's inside of the room, right? So you could sort of spy on people from outside of their house, or spy on your teachers if they're having a conference in a different room with a window. So I wanted to build this thing and see if it was actually possible. And the rumor was like the government has been doing it for years and they've been spying on everybody. And they probably are and were. But this one I used a big 5 milliwatt red laser so you could see it. If I was the government, I'd use a laser that you couldn't see. But I used a red one and it worked okay. I could play music in my room. I had to turn the stereo up all the way, and it would move the window a little bit, and I could like barely hear it. So it sort of proved the concept, and that was something that I just wanted to do because I didn't know if it was possible. So that's creating something new. A little more recent, a few years ago, I was on a TV show called Prototype This, which was on Discovery Channel, and it's on Netflix now, which was basically 4 people building prototypes of crazy things. So if you want to see like gigantic, ridiculous things like 10-foot giant boxing robots that punch based on the movements of players outside the ring, that's Prototype This. So that's creating something new. That was just a completely out of our head idea that we're like, what looks good on TV that we could that would be fun and we can like build something gigantic. So that had, we had pneumatic control and accelerometers, wireless accelerometers in the boxing glove. So as you threw a punch, the robot would do the same thing. It was totally cool. Did you see that movie Real Steel? Yeah. The rumor is that Real Steel was based on this episode of the show. I can't confirm that, but yeah. So that's creating something new, just totally ridiculous. Here's another one. That's me wearing full firefighter gear. This was another one from the show, which was a high-tech firefighter pack. And firefighters, most of the time, they have gear that's kind of outdated and old. But we wanted to try to design something that would be really cool, that they could go into a fire and put out fires with like a superhero sort of, and spray fire extinguisher out like Spider-Man. We had a heads-up display that they could wear, and they could see through all the smoke and figure out where other people are in the room. So if you imagine a fire and there's smoke everywhere and, total chaos, they can walk in and know exactly where people are so they can pull them out and rescue them. What else did we have on there? We had an identification system, so not only could the firefighters see through the smoke, they would know where the other firefighters are, because that's an important thing, is you always want to keep your people together. So that was a kind of fun one that actually had, as opposed to the boxing, which was just for fun, this had a real purpose. And we tested this with real firefighters, and they got to actually use it. So, you can actually create things that help people and that have a further goal than just for fun. Modifying electronics, taking something that already exists and making it do something else, or tweaking functionality a little bit. This is my favorite example. And it's a garage door opener for my parents' garage door. I built this when I was, 16 or something. And the way the garage door opener works is that you'd have a transmitter, which is what this is, and you'd set a certain code on the transmitter, and you'd set a receiver on the garage door to match that code. So when I push the button, it sends a code. If the receiver matches that code, it's going to open the garage door. If it's not the right code, it doesn't. Just like a password. If it's not the right password, it's not going to open the door. But on the garage door transmitter, there was a set of switches, 10 switches that you would set. And that's how you would set your password. And the 10 switches could be on and off. So there's really only a finite number of settings, right? You can have on, off on every single switch. So that ends up being 1,024 possible combinations. You could, if you wanted to, just individually try every combination by hand until you got the password that was right. But I decided to build some electronics to do that for me. So I have a little circuit in there that will cycle through every possible combination of those passwords and open any garage door that uses the system. So that was fun. I didn't go into any of the garages that I opened. Again, not breaking the law. But it was a fun thing to show, look, this is really bad security. And at the time, this was right before the security industry became this thing. But this was my first time of building something that I could actually show to people and say, look, we need to change the way this is done. And my parents, I showed it on my parents' door, and they're like, that's great. They patted me on the back, and they're like, okay. So they got it a little bit, and that's sort of the response that we see from a lot of vendors these days, like people that sell hardware products. If we find problems, they're like, okay, good job, go away. And then I kept, doing things to make them realize that it was important. And eventually they moved all their stuff out of the garage, all the important stuff. But that's a fun one. Here's one that I just started working on. It's incomplete, which is why the picture is incomplete. But it's anybody have the Tooth Tunes toothbrush? Yeah, somebody does? Awesome. So it's a toothbrush that will play music for 2 minutes. And when you put the toothbrush on your teeth, through bone conduction, it feels like you're actually hearing the music. It's a really cool concept. So it plays music for 2 minutes, because that's how long you're supposed to brush your teeth. So I bought one of those, and it plays Dynamite, the song Dynamite, and which is an okay song. It's all right. Not really my style. So I was like, okay, I'm going to modify it and play my own song that I like, so I can brush my teeth to music that I like. So what I did is I took all the circuitry out of the bottom of the toothbrush and basically threw that away. I had to create my own circuitry that would play songs. But first, I wanted to see how it worked. So I took it all apart. The kind of speaker part that vibrates the toothbrush head, which is how you hear the music, just had 2 wires. So I could treat that as a regular speaker. And then all I had to do is build some circuitry to play sounds or songs off of an SD card. And that's something that in the past few years ago that would have been really difficult, but I just did a Google search for SD card wave file, playing wave files. And there's tons of circuits, so I built up a few of those to find the best one that I could do in the smallest form factor. And then I loaded a song onto the wave file, and now I can play my own song. The next step is to cram all of that circuitry back into the toothbrush and then use it. So modifying electronics. And there's absolutely no reason why I need to do this, right? I know how to brush my teeth. But it's fun, right? It's just something cool. Testing security. Since we're here at DEF CON, there's a lot of security-related stuff. There's all sorts of products out there that claim to be secure, antivirus and hardware things and everything. But really, it takes a hacker, it takes a hardware hacker to test security and tell people if it's good or not. Because you can't really trust the people selling you stuff because they want to sell you stuff. So it's up to us to go to them and say, no, it's not exactly secure, or maybe it is secure. Maybe they, deserve a pat on the back. But in general, it's always good to test things on your own. And I'm naturally like that. I don't normally trust what people say. I want to do things on my own. And that's part of the hacker mindset. Even as far as a waiter brings a plate to the table at a restaurant and they're like, don't touch the plate, it's really hot. And I always touch the plate to see if they're telling the truth. So here's one. You can't really see the screen, so this one's actually not really going to be that exciting. This was an example of testing the security of the parking meters in San Francisco. This is some work I did a few years ago when I just moved to San Francisco, and I noticed they use smart cards that you buy that have a certain number of dollars on them when you put them into the parking meter, and the meter will add money to the meter and take money off of the card. And I was like, that's cool. I'd never worked with smart cards before, so for me it was a great opportunity to learn something new. So I was like, okay, I want to see how this system works. And I went through this whole process to figure out how it works, and then created my own custom smart card to see if I could defeat the security. I wrote some code, loaded it onto my own card, and it's completely impossible to see on this screen, so you have to trust me. I'll play the video anyway. Maybe you'll be able to see it. So normally you'd put the card in, it would show you a value, and it would say like $20 remaining or something. In this case, can you barely see that? $999.99. That's a lot of parking. Yeah, like 4 hours worth in San Francisco. But that, the maximum value parking card you could buy is $50. There's no reason the system should allow somebody to put in a card that says it has $999.99. But I could have gotten free parking for the rest of my life. But I decided to tell the city about it and say, hey, you guys have a problem. If I know about the problem and I'm a good guy, there's probably people out there ripping you off. And if you're getting ripped off, I'm paying for that because I pay taxes and I'm paying for these losses for the city. So I thought it was sort of a noble cause for me to go and tell them about it, and they acknowledged the issue. I did try that card a little bit more recently, and it does give me an error, check card invalid. So at least they've probably set the limit down to $50. So it's a good first step. That's testing security. Here's one you guys might like. Are you old enough? Did you see Terminator 2? No? Okay, you will at some point. A few of you guys did. Okay. Sort of for probably like teenagers, I guess. This is some work that a friend of mine, Barnaby Jack, demonstrated at Black Hat in DEF CON a few years ago of hacking ATMs, machines where you get money out of from the bank. And this is basically an ATM. It looks big and huge and complicated, but it's really just a computer running some sort of code that somebody wrote on there. I'm sure you've heard about, people that are hacking software types of stuff. It's really not a very complicated thing, but people just never looked at them because they thought, oh, well, it's a piece of hardware. It's probably secure. But Barnaby's like, no, I don't think so. I'm going to look at it. So he ended up buying an ATM, brought it into his house, started analyzing it, figuring out how it works, found a bunch of problems in it that would let him basically load new code into the ATM to have the ATM do whatever he wanted. And it was a Windows CE based device, so it wasn't anything even custom. So he could load his own code in there and have it do whatever he wanted, just like writing a program on the computer and running your program. Same exact thing, except what he did in this case is have the thing spit out money. So I'll show you the video. It plays some music, so I'm going to just hold the microphone up to the speaker, and you'll probably be able to see it. But let's give it a try. It's playing music. And there's the money getting spit out of the ATM. He could basically pick, because all these ATMs are networked, so he could basically identify an ATM, force it to spit out all this money, and then have somebody go collect all the money and run away. But since he's a good guy, he figured this out, went back to the ATM company and said, here are a lot of your problems. You'll probably want to fix these. And they did. Reusing technology. If you have stuff that your parents are throwing away or that you find at school or something, some piece of electronics or some product, you can always reuse it. You can always pick the pieces out and use them for other projects. On the left, I have an old Macintosh computer that I turned into an aquarium. So that was sort of cool. You can make bicycles out of crazy parts, and that bottom thing is like a coffee table made out of circuitry. I mean, anything you can think of, you can do. And that's the beauty of hardware hacking. I just have 3 little videos. When I was doing the TV show, the producer said, what are your 3 favorite tools that you like using? And I said, soldering iron, multimeter, and oscilloscope. And these are the tools that I use on a daily basis. How many of you guys have used the soldering iron in the workshop area? Almost everybody. Okay. So I'll show you a video about it, even though you already know about soldering. I'll show you kind of funny little video that I made explaining the tool and explaining the multimeters and the oscilloscopes. Basically just to show you there's lots of tools out there that you can use. So the stuff, might seem intimidating when you see a circuit board and you're like, well, what do I do with it? If you have the right tools, you can do it, right? Just like if you wanted to build something out of wood, if you have nails and you have a hammer and a saw, you can build stuff if you have the right tools. It might be harder if all you have is a scissors. So if you get the right tools, you can do this stuff and it's not so hard. So let's see, here's the soldering iron.
I've got a confession to make. Soldering might not be as cool as cutting, grinding, or welding, but when it comes to must-have tools for building electronics, it don't get no hotter than the solder. A soldering station has 2 main components. A soldering iron. This thing gets hot, up to 700 degrees hot. Then, we have the solder. This is the magic behind it all. It's a special metal alloy that melts and helps fuse components together so they stay on the circuit board. For example, here's the circuitry I built for the personal airbag. Without this thing, we wouldn't be able to detect when the person was falling and when to deploy the airbag. From the 6x6 all-terrain vehicle, this was a battery management system that sat on top of each of our batteries. For the anger management demolition derby, there's a lot of solder in here. Soldering isn't all fun and games. It's pretty dangerous. These fumes, they're toxic. You don't want to breathe them in. And the stuff can get in your eyes. It's not good. So even though soldering isn't that sexy, and it's a little bit dangerous, without soldering, all of the electronics in all of our builds would have fallen apart. Literally.
So there's soldering. Could you guys actually hear that at all? You could. Okay, good. I can't hear it up here, so. Okay, so that's soldering. Here's the multimeter. This is a really cool piece of equipment.
So your car won't start and you think it might be the battery? There's one way to find out for sure. The multimeter. The multimeter. The multimeter, yeah, extreme. When it comes to electronics, this sleek little baby right here can measure just about anything. Buttons, look at all these buttons. This thing can measure all sorts of aspects of an electronic system, like voltage, current, resistance, capacitance, and so much more. So if I want to test if I have a good connection, just set this to continuity, touch the probes, I'm good. Buttons. The multimeter is definitely one of the best diagnostics tools we have up here in the lair. It's so versatile, it can even measure temperature and tell you if you're sick. Uh-oh. Doctor!
Our temperature probe wasn't working in that video. I wasn't actually sick. All right, then the oscilloscope. This is by far my favorite tool. So here, I'll show you about it.
One of my favorite tools up here in the lair is a digital oscilloscope. That's the digital oscilloscope. This thing is like the Swiss Army knife of electronics measurement tools, and it lets you visually see an electrical signal and how it changes over time. Check it out. Here's a remote control. Have you ever wondered how these things communicate with your TV? With the oscilloscope, I can see the signal that's being transmitted from the remote control to the television. Here's what it looks like when I want to turn off the TV. This is what it looks like when I change channels. This is a really high-end oscilloscope. I can adjust the size of the waveform and the time that I'm measuring the waveform. Waveforms are so cool, I'm even wearing one on my shirt. It sounds like this. I'm wearing a sound. I use this baby right here for every electronics project that I ever work on. For one build on the show, I used it to debug the anemometer circuit. I want to thank everybody for spending time with me and my oscilloscope. We'll see you later. Let's go.
So I showed that video to my son, who's 4.5, and he says, "Daddy, why are you hugging your oscilloscope?" And I thought of a good way to explain to him how much I loved the oscilloscope, but I couldn't. It's just a good tool to have. Because without the oscilloscope, you can look at a circuit, right, and you can see it's blinking a light or doing something, but you can't really know what's going on each of those signals. Some other really cool stuff you can do, depending on if you have access to X-ray machines, which your dentist has X-ray machines, or your veterinarian has X-ray machines, maybe your parents have access to one. You can actually look inside of electronics and see what's going on inside the actual chip, see how things are connected, and that's really awesome. Then you have advanced stuff like decapping chips. So if you look on your badge, all those little black chips have little tiny silicon dies inside. It's almost like a city inside. It's almost like a circuit board inside of each of those little chips. Microscopic. If you look with a microscope, you can see different portions of it. And if you zoom down close enough, you can see individual transistors that form the entire chip. So what you can do is take a chip. If you're doing security research or you want to try to get information about a part, you can use chemicals or you can use special machines that will remove the plastic, the black part of the chip, and actually get to the die inside, and then you can zoom it out and see what it looks like. So really cool advanced stuff, and there's been some talks at DEF CON about how to work with those types of chemicals. Very dangerous stuff, but also very cool. So I guess sort of the final kind of summary of hardware hacking. Why do it? Why is it cool? What to do? Basically, open things up. See how things work. Experiment. And don't be afraid to make mistakes. That's the one thing. When you're in school, you take a test. It usually ends up being it's right or wrong, right? And that's okay because it's, your teachers are trying to figure out how much you know or how much you understand what you're working with. But really, making mistakes is okay, especially if you're experimenting, if you're wondering how things work and, you want to just try something and see if it's going to work or not, just do it. Don't be afraid of failing. It's one of the things when you fail, you end up learning more, right? It's like if you take a test and you get a problem wrong, you go back and try to figure out why you got it wrong so you don't get it wrong next time. But with electronics and hardware hacking, if you want to try something, maybe it's not going to work. There's stuff that will take me weeks to try to get a circuit right. Thomas Edison, right, took him, I don't know how many years it took him to get something right. So failing is okay. You're just one step closer to getting it right eventually. And don't let anybody tell you like, oh, you're stupid, you're dumb if it doesn't work. Like that doesn't matter, right? If you like it and you love it and you want to do it, you can do it. I guess the final thing, you're never too young to start. You're all older than this little guy here, who is my son, who is that picture. I think he was maybe a year old or a year and a half or something like that. He's 4.5 now, and I have a younger one that I'm going to soon start to introduce soldering to. But you're never too young to start. You've already started with your badges, and you can go and now look around and see what else has electronics in it. See what else you can try to build. Think of things that you want. If you've always wanted your own robot or your own toy that doesn't exist, Or maybe it exists and, you know, you haven't, there's no, you know, your parents haven't bought it for you, or there's no special occasion coming up or something. It's like, okay, just build it yourself. Try to put it together yourself and see if you can do it. And that's the most satisfying anyway, being able to do it yourself and then show everybody that you did it instead of just going and, you know, buying it from a store. So I think that's it. Let me see. That's it. That's the end. So thank you. Enjoy the rest of your time here. Ooh, extra 15 minutes. Do we have any questions? Anybody, any questions about anything? Yep. So the question was, did I learn all of this stuff in school or did I teach myself? And the answer is both. I started learning about things on my own through magazines and just through reading, because there was no internet when I started. There were computers that you could connect to bulletin board systems and talk to people, but it wasn't the internet. So I couldn't just go Google stuff. So I started mostly on my own. And when I got to, once I got to college is when I actually started learning about it. Because there were no electronics classes or anything at my schools when I was younger. So I just did on my own, went to school, studied electrical engineering. So now I had the formal experience and I had the real world experience, which I think is kind of the best of both worlds. And then I went off and worked at a real product development company to learn even more about the process. And now I'm just on my own doing it. So I think it's important to do things on your own and to learn it in school if it's something that you really like. Okay, so the question was, what parts did I use to make the perpetual water slide, which was one episode of the TV show that was this giant 30-foot water slide simulator. So you could sit in the bottom of this gigantic donut of water slide, and it had water in it, and it was computer controlled that would basically let you ride an unlimited water slide, which was totally awesome. That project took 5 weeks to make. And most of that was, I think we had like 20 people from San Francisco, artists and welders and stuff, building this giant structure. But the control side really was, there was some hydraulic motors and stuff to make the thing move up and down and left and right and go side to side. And then we had, yeah, basically a computer running some code, like a Macintosh running some code that was controlling all the hydraulic stuff. So really all of the magic was done in Zaza's code, where he wrote a bunch of stuff to simulate the different movements of the water slide. So that one was very software intensive, but that was my favorite project, an amazing thing to ride. But it's all gone now. The production company took it apart once we were done, which is too bad. Would have been a good thing to show at like Maker Faire or something. Any other questions? Was that a yes? No? No? Okay. Well, I guess there's a little bit of time. You could always run back to the workshop area, or I guess hang out here. I don't know what the next talk is. Oh, okay. We're not sure either. So, thanks again.